For decades, Bill Nye, the science guy, has captivated audiences with groundbreaking scientific discoveries and the intriguing mysteries they uncover. His passion for the cosmos has fueled public interest in the vast unknowns of outer space. Now, Nye breaks his silence to discuss the latest revelations from the James Webb Space Telescope, JWST, offering humanity an unprecedented glimpse into a universe that existed over 13 billion years ago. These insights are revolutionizing our understanding of the cosmos and shifting our perspective on life itself. The James Webb Space Telescope, which was successfully launched on Christmas Day 2021 after years of development by NASA scientists and engineers, began its operations in mid-2022. By June of that year, the telescope had already identified thousands of previously unknown galaxies, many older and farther away than anything seen before, some even predating the Hubble Space Telescope's oldest discoveries by over 150 million years. The JWST has the capability to collect light from distant exoplanets and stars, enabling scientists to determine their composition and trajectories. According to Nye, this data is already revealing the atmospheric makeup of planets light years from Earth, offering clues about their potential to support life. One of the most iconic cosmic structures ever captured by Hubble was the Pillars of Creation in the Eagle Nebula. While Hubble provided breathtaking visible light images, it couldn't capture the actual processes of star formation within the pillars. Now, the JWST's infrared imaging reveals protostars forming within the dust and gas, appearing as tiny, red dots. These are massive, star-forming regions, many times the size of our solar system. Nye explains that once enough material accumulates at a protostar's core, hydrogen fusion ignites, raising temperatures dramatically to around 2 million degrees Celsius. The different colors seen in Webb's images represent varying infrared wavelengths, largely invisible to the human eye, but revealing an unseen universe in incredible detail. The search for planets beyond our solar system, exoplanets, has intensified. Since the first were discovered in the 1990s, while thousands have now been confirmed, only a few have been directly imaged. One of the most notable is HAEP 65426b, a gas giant almost 12 times the size of Jupiter, located 100 times farther from its host star than Earth is from the Sun. Using advanced instruments, including coronagraphs and infrared cameras aboard JWST, scientists were able to capture the planet's image directly, an impressive feat due to its extreme distance and faint light. Among Webb's most mesmerizing captures is that of the so-called Phantom Galaxy, or M74. Though difficult to see with the naked eye, its spiral arms and brilliant core become vivid through the telescope's infrared imaging. The new Webb image reveals intricate filaments of heat-emitting dust and gas, previously hidden. Scientists from the European Space Agency, ESA, as part of the FANGS project, combined data from both Hubble and Webb to create a composite image that highlights features in both visible and infrared wavelengths. These images are critical in studying star formation, the composition of dust particles, and the structure of galactic arms in unprecedented detail. In another notable image taken in July of the previous year, Webb captured WR140, a massive, Wolf-Rayet star nearing the end of its life. Surrounding this star were a series of odd concentric rings with a square-like appearance. These rings are thought to result from interactions with a nearby companion star, causing periodic ejections of stellar material. Unlike typical diffraction artifacts in telescope imagery, these rings are natural and represent the dynamic and volatile behavior of dying stars. In mid-December, scientists using the Webb telescope announced the discovery of 4 of the oldest known galaxies, dating back 13.4 billion years, just 350 million years after the Big Bang. This marks only about 2% of the universe's current age. These galaxies were identified and confirmed through redshift measurements obtained via Webb's near-infrared spectrograph. The galaxies exhibit a redshift of 13.2, the highest ever recorded, validating their extreme age and distance. This achievement showcases the telescope's ability to not only locate distant galaxies, but to verify their ancient origins through spectroscopic analysis. Closer to home, but still 700 light-years away, JWST has also studied WASP 39b, a scorching gas giant, orbiting a star in the Virgo constellation. This planet, 8 times closer to its star than Mercury is to the Sun, has a thick atmosphere containing sulfur compounds, silicates, and even sulfur dioxide. Using its sensitive spectrographs, Webb identified carbon dioxide in the planet's atmosphere, marking one of the most detailed examinations of an exoplanet's atmospheric chemistry to date. These observations underscore the revolutionary capabilities of the James Webb Space Telescope. As Bill Nye emphasizes, the telescope is not just a successor to Hubble. It's a monumental leap forward in our quest to understand the universe. From capturing ancient galaxies to analyzing the potential for life on distant worlds, Webb is reshaping the frontiers of space science.